Provider my fellow friends. I'm going to present you the description of biodiesel production plant. It is a trans-esterification process, which is the process of conversion of triglycerides or fats in vegetable oils or animal fats in biodiesel. The first step of the process is to prepare the catalyst for the reaction. Methanol and strong sodium hydroxide is well mixed in the mixer before fed to the reactive distillation column. In this reaction, methoxide is produced and reacted with fatty acid, which is a triglyceride in this case, to form methyl ester. Methyl ester is the biodiesel in this case. High water production can lead to unwanted side reactions such as soap formation or saponification. Therefore, methanol must be used very dry as possible. So 3 moles of methanol is fed from the recycle stream at the top of the RD column is fed with triglyceride to ensure complete reaction. So trans-esterification process will take about at 40 degree to 65 degrees Celsius. At 65 degrees Celsius is the boiling point of the methanol. The product which produced via trans-esterification process comprises of biodiesel, glycerol, and unreacted methanol at the bottom. RD is centric acetylene tank. The higher density of the biodiesel will settle at the bottom of the tank. At final stage, light component of methanol and glycerol separates based on the boiling point difference in the flash graph.
Fishbone diagrams effect is the reactive distillation column failure where less flow to the partial boiler, and the causes for materials are less flow of feedstock to reactive distillation, which means less product and less flow rate. Then restriction of flow in pipe could possibly due to scaling or corrosion, and we have high feedstock with excess water, which means we have more side reaction causing more foaming and production of soap and causes an increase in viscosity, and then we have less flow rate of product. Moving on to measurement, it could be possibly due to faulty wrong flow meter readings at around the RD, and we have a wrong type of flow meter selection. Usually we normally use for high viscose biodiesel test, we use turbine flow meter, and corrosion scaling grass could possibly affect the moving part or the probe of the flow meter. Moving on for the equipment, we have falling of overhead condenser, which means it falls means you have not access methanol is provided to the recycle stream. Floating means we have high pressure, differential pressure on the RD, and we have high liquid hold up on the tray due to excessive vapor, causing less liquid flow at the bottom of the tower. And we might have pump, valve, and pipe leakage due to its component failure. Like let's say for pump, we might have conceal, valve, we might have seat, pipe, we might broken flanges or gasket. And moving on for method, we might have a wrong production procedure setting, maybe before after shutdown and startup there could be wrong setting given, and for wrong mixing ratio of feedstock they could possibly affect the material balance of the whole production plant due to the wrong input and input of the feedstocks, causing less flow of the product. And then we have no proper working instruction, maybe there is no supervision during the time of the incident happen, and we might not have no proper record keeping, like we should have proper SOP writings, you should have all the preventive and corrective maintenance records, and you have quality management records. Moving on for process parameter, we might have very low temperature. At very low temperature, you might at winter normally you might solidify the fat. At a high temperature, it will affect the separation of the distillation column. If too humid means there will be a lot of moisture, but especially for sodium hydroxide, there may be chances of cross foaming after the reaction. And there's possibility like raw material contamination, such presence of dust, pollen, debris, and dirt on the equipments where cleaning in place is not done, and will affect the overall equipment process later, causing less flow rate at the end. And we have people for people, we have commonly improper maintenance is done for all the equipment I've mentioned. Maybe that's an error there. And then we have inadequate training. Maybe there's a lot of freshers there and they are not giving trainings such as on-job trainings before they can run the plant. And we have maybe there's majority of unskilled labor and there's less experienced people guiding them. It could be one possibility.
Hi, my name is Muhammad Zafri bin Muhammad Zakidin and I will explain about the pump feeding methanol to the mixing tank failure leading to less methanol flow rate. This is a figure of pump failure fishbone which consists of 6 causes, which is material, measurement, equipment, method, environment and people. Firstly, on the material is pump shaft diameter is too small, causes a premature seal and packing failure that lead to the leakage. Next on material is board is not serving the torque but only to hold the insulation plate, causes a coupling fail to send power to the driver. Next causes is measurement. Current are not measured will cause overcurrent will be lead to the pump overload and cause a shaft deflection. Voltage. If the proper voltage is not available to pump, it will use more amperage to the compensate, resulting in excess heat that can lead to driver failure. Next on the cause of method, wrong startup procedure. As example, pump startup in a reverse rotation can result in the contact of metal part and heat generation. No proper maintenance not appropriate for the risk involved. Did not perform the preventive maintenance, predictive maintenance, and corrective maintenance. Next on the method is valve position is wrong. As example, operate the pump below the minimum rated flow or with the suction or discharge valve closed. This condition can quickly lead to the pump failure. Next on the cause of from people is the lack of training operator on the alignment of shaft that requires to join the coupling point, cause the shaft will be failed to rotate as common. Unexperienced operator fail to control an emergency maintenance, fail to improve the given procedure to increase the efficiency of the pump. Next on the environment, this is a picture of cavitation that happen in the impeller because of the low pressure of the suction of the pump. Next on the environment, there's sometimes unwanted material such as dirt, dust that suck in the rotor because the rotor fail to rotate as normal. This is important part which is fluid viscosity. When the poor fluid viscosity might tend to access heat to the pump, but if the viscosity is too high, lead to cavitation inside pump. Equipment. First is impeller. Wrong direction of impeller will make the reverse that affect the pressure and discharge rate. Next is bearing. Lack of bearing lubricant which can cause the increase of the friction towards shaft. Lastly, on the equipment is packing. Packing fail to seal that can be detected through the increase of leakage. Packing material could be brittle once worn. Thank you.
Assalamualaikum and hi, my name is Muhammad Hafiz bin Khairul Anwar and I will talk about the flash drum failure fishbone diagram. This is a fishbone diagram of this problem. It has 6 categories as shown in the picture. The first category is a material. In the first picture, we see the example of erosion corrosion on the wall of a flash drum. It is caused by the impingement high velocity of biodiesel to the wall. The second picture is the example of corrosion thinning on wall of the flash drum that caused by the low residual hydroxide concentration of the biodiesel. The third picture is the example of corrosion of the top dome in the flash drum that may be due to condensation of the acidic vapors due to condensation of the vapor forming to corrosive liquid phase on the metal surfaces. Next category is the measurement. The first problem that we might encounter is the formation of scaling that will narrowing the inside diameter of pipeline. Another problem is poor control and flow instability that caused by the error level measurement due to wrong calibration. Picture shown in the example of scaling found in the pipeline due to excess water that has higher content of mineral such as calcium carbonate. Next category is the method. The first problem that we might encounter is the operation method. We suspect the reason why no methanol flow out the flash drum is the wrong calculation of methanol and sodium hydroxide ratio. The next problem is wrong calculation of the concentration of the biodiesel entering the flash drum. Next category is the people. The first issue for people is lack of training. People with lack of training most likely to make mistakes. Next is a lack of maintenance. The problem can result in unsafe condition and injuries. Another problem for people is unskilled worker. Unskilled worker could spend more time seeking help to do their jobs. Next category is environment. First problem we encounter for environment is high vertical force that led to the feed inlet distributor damage on the inside. Next problem is a high surrounding temperature that led to polymerization or oxidization of the biodiesel product as in the picture shown. Last category is our equipment. The first problem we encounter for equipment is the flooding in the flash drum. It is caused by the damaged mist extractor that led to unable to collect small liquid droplet from gas stream before it leaves the separator that caused flooding. Next problem is the leakage of the pipeline and flash drum. The leakage of the pipeline is due to the fluctuation of the temperature that cause the pipe to expand or contract, while the leakage of the flash drum is due to the high quality material kept in flash drum in long period. Last problem, last problem we encounter for equipment is the pump not functioning. The reason why the pump is not functioning due to cavitation that will indicate the blockage in the suction line of the pump. The net reason is due to fouling. It occurs when particulate matter adheres to a pump internal surfaces. Thank you.